All right, so you've probably heard about this on the blogs, you've heard it on a bunch of cool websites. This is a very interesting product, and it's really important for a lot of people out there. It's going to save a lot of big companies, a lot of government firms, a lot of money. This is the NVIDIA Tesla C1060 computing processor, and what the Tesla does is it gives computing scientists and researchers, they give them like the power of, let's say, a small to a medium-sized supercomputing cluster, but in a workstation form factor. Like, this is just a video card. It looks like a video card. It'll fit in your computer, but it gives you the power of like a room of rack systems. Now, what this does is it pretty much enhances GPU and parallel processing and puts it in a small form factor with a PCI Express 2.0 bus, so you can throw it in a workstation and have this immense amount of power. It actually can do over a teraflop of power, of raw processing power, and it introduces something new, which is called the double precision floating point, which is something that's kind of new. It still does the single, obviously, but it does the doubles. Now, what that means depends on what you're going to use it for. Something like this is going to be used for people doing oil and gas exploration, computational finance, fluid dynamics, medical research, weather modeling. I mean, this is not for regular people. They're going to be using that, and what makes the whole thing possible is that you're utilizing NVIDIA's CUDA API, which is their C programming language. It has a great SDK on their website you can download to write custom programs for this type of hardware. Pretty much rather than using your CPU or a cluster of CPUs to do these intensely parallel tasks, you use parallel processors. And this has 240 stream processors in there, or ALUs, so they're going to do everything really fast and all at the same time, parallel. And if you don't really understand the concept of parallel, well, this is not a card for you. But if you're just curious and you're watching this video, at Envision 08, the guys from Mythbusters did a great demonstration. Watch it, and it'll give you the idea of how parallel computing works. Now, besides the 240 stream processors at 1300 megahertz, it's got 4 gigabytes of GDDR3 at 800 megahertz. It's got a 512 megabyte memory interface, and it gives you easily over 100 gigabytes per second of memory bandwidth. Now, to power this thing, you're going to need at least 2 6-pin PCIs, which you can do one here and one, I guess, block out one of these, one there, or you can just do an 8. If you just do an 8, you're fine. But if not, you need to do 2 6s. So don't think that you have to do the 8 and the 6. You got to do one or the other. Now, those 240 stream processors that are all up in here, they are literally very, very powerful. They're the 10 series stream processors from NVIDIA. They have a floating point unit. They have a logic unit, they have move and compare unit, and they have a branch unit. Also on here is a thread manager. I'm actually not sure if it's here or here, but there is a thread manager that can support up to 12,000 threads with zero overhead for thread switching. So you can manage massive data sets. You also have, remember, 4 gigabytes of memory on board. So huge, massive data sets are going to be compiled through here. If you look over here, obviously this is just a computational unit, so there is not going to be any graphic slots on here. It's not what this is for. And this is your PCI Express 2.0 bus down here. Now, if you want to know, can I use a single wide PCI Express, an X16 instead of an X16 2.0? Yes, you can, but you are going to lose some of that bandwidth, and you kind of don't want to do that when you're trying to get massive amounts of computational power over 1 teraflop per card, so keep that in mind. You do need a good amount of power. This will draw about 150 watts, so it's really nice if you'd have about a 600 watt power supply just to run one of these. But the best part about the Tesla C1060 computing processor is that with this type of technology and the right kind of motherboard and the right kind of system, you can build yourself a supercomputer that will fit inside a regular computer case. And I'm not even kidding. Here's how you do it. First thing you need is the right motherboard. You need a motherboard that supports your Opterons or your Xenon processors, or nowadays you can use your Core i7, which is the latest platform, which is also very, very fast. What's most important, though, is you need to have at least a minimum of 3 or 4 PCI Express 2.0 slots. This is PCI Express 2.0, and it works best. Now, these have 4 gigabytes of memory each. You would need an additional 4 gigabytes of system memory per card. What you're going to do is you're going to get an awesome motherboard like a Skull Trail that has 4 PCI Express 2.0 slots, or a Core i7 motherboard that's really high-end, especially one that has workstation stuff like SAS drives on it. And then you're going to get about minimum 12 gigabytes of FBDIMMs, or triple channel DDR3, whatever it requires depending on your board, and you're going to get 3 of these Tesla cards. You're going to load up all 3 of them, and these things will actually scale fully. And it's not like SLI or anything with computers and gaming. We're talking about full, all-out scaling, 1-to-1 ratio. You also get, your final card would be either a Quadro FX card for 3D modeling, or a Quadro CX for editing, an MVS if you need to set up a bunch of monitors, and then pretty much make sure your case has 8 expansion slots, because these are going to take 222, and then your card, your graphics. or your workstation card, and then a PSU that's going to support probably 1200 to 1500 watts, because you are going to use it. If you use all that together, you load up Windows XP 64-bit or Linux 64-bit, and eventually they're going to have one for Vista and Windows 7 in the future, but that's not out yet. It's either going to be XP or Linux for now, and you literally build a supercomputer. I mean, I'm telling you, like a room of racks of CPUs, you're building it in a case. You put some SAS drives in there, you get some big monitors, and you have an amazing workstation for a scientist, for a researcher, for medicine. You can do so much with it, and the best part is since you can build a system like that for around $10,000 versus a $5 million supercomputer, you can actually give all your people in your staff one of these workstations, and they're going to have the power of your cluster at their desk, and they don't have to share the cluster anymore. So now if they have a problem that they need to figure out, they can simply insert their calculations and do whatever they need to do with their models and just shoot it right at their desk. They don't need to wait scheduling cluster time for processing, and it's actually going to be much faster than some of the $5 to $10 million supercomputers that are out there. So it just goes to show you how immensely powerful the NVIDIA CUDA platform is, how powerful GPU processing is, and this is stuff that's right now for scientists, but it's also moving very mainstream. In the future, you're going to see it with stuff like Quadro CX cards from NVIDIA. They do the same thing, but for home systems, and they're meant for CS4 for doing video editing, and for Photoshop stuff. It's using GPU power for processing stuff that it's better if you do it parallel, and it gives you a huge boost in performance. But this is on a whole other level. This is for scientists and computing researchers and all these crazy people doing all this stuff, computational finance that I really don't understand, but it's a great product. Definitely look into it for your company, and definitely consider it if you're doing a lot of research that requires this type of parallel processing. If you have any questions on it, don't send them to me, send them to NVIDIA, because I don't know that much about this product, and goodbye. So if you're a scientist or a researcher and you want to get some more information on the NVIDIA Tesla C1060 computing processor, type in P56-1060 into the search engine of any of these major retailers. For Computer TV, I'm Albert.